go. All right, let's talk security. Hi, everybody. Let's get to work here. My name is Jim. Hey, thank you for actually sticking your, just for a note, you're at a conference, it's Monday, it's 5:30 p.m., and you're still here going to listen to me talk about security. So I'm very grateful that you're here, first of all. This is a really fast talk. I'm going to go through a lot of information in a short amount of time. It's being recorded, and I'm going to publish the slides at the conference. So if you miss any detail, ask me at the end, but also pick up the presentation. My name is Jim, by the way. I'm an educator. I teach developers how to write secure code for a living. I've been a developer myself for over 20 years. I wrote a book for the Oracle community on how to write secure web applications in Java. I am from Kauai, so aloha hui ho. Aloha malamapono. I'm glad you're all here. Let's get to work. Don't hack without legal written permission, or at least a good lawyer, because you're going to jail. Let's move on. What is the OWASP Top 10? Well, OWASP Top 10 is a published list of risks, of attacks and similar type of topics from the OWASP Foundation. The OWASP Foundation is a nonprofit. It's the OWASP Top 10, the Open Web Application Security Project. This is a very popular project. In fact, it's cited by PCI DSS. That's the credit card industry's data security standard. If you process credit cards, you have to follow PCI DSS. And if you're doing it on the web or with an API, you have to follow the OWASP Top 10. Now, this list is meant for just awareness. It's not a standard. So the moment PCI DSS cites the OWASP Top 10, they're demonstrating their incompetence as a standard body. I hate to say it. We should be looking at the ASVS. That's a comprehensive secure coding standard. The OWASP Top 10 is just an awareness document. But why are we here? We're here for awareness. So the OWASP Top 10 is a good place to lead. This is what we're going to be looking at, the OWASP Top 10. This is the final version, the second release candidate that was published. A lot of these, hopefully, you know about already as developer. A few new things have popped up. That'd be XXE. We just mentioned it in the prequel here. This is external entity references against XML services. I know XML is not very hot, but we still use it, and it's the way attackers compromise your systems. I know it's not fun, but we've got to maintain legacy software for security. The other new category is insecure deserialization. We'll look at research from Hewlett-Packard, Alvaro Munoz, who first pointed this problem out. If you're accepting untrusted data and you're deserializing it, we could run operating system commands against your server with relative ease. We also see logging and monitoring being brought up for the first time. There's a theory with a lot of big companies who are really deep into software development. The theory is we can't write secure code. We're not going to be able to pull that off. I don't agree with that, but it's a legit philosophy. So their philosophy is don't worry about secure code, log everything. Massively log everything in great detail so we can at least see attacks in process and handle it. I don't like this theory, but it's still important to log, even though it's a boring topic. Let's start with injection. Who here has heard of an injection attack before in development? All of us have. I'll go through this fast, right? The main type of injection is called SQL injection. This is where I can inject data in SQL. SQL is still the most popular way to talk to a database. Anybody use Hibernate or Object Relational Mapping Engine? Yeah, how much time do you spend tuning your configuration files for Hibernate? And when it's stressful, and it's a time-sensitive issue and your database config layer is broken, you'll be spending possibly days managing that object relational mapping metadata. A lot of companies still do SQL for good reason. Easy to tune, easy to maintain over time. I digress. And so you tell me, is this a legit email address? You're saying no. What's your name? It's Neepan. You say no, not a legal email address. It looks like it's not legit, and I think it's a fair answer. But guess what? It's totally legit. Guess what, Neepan? It's not only legit. You know what else it is? It's live right now. If you don't believe me, I respect that lack of belief. It's okay. But if you want, email me there. I'm not going to save your. I'll just respond with one word only. I'm going to say, believe. It's real. The point I'm trying to make here is this a valid piece of data? If someone's editing their profile and submitting an email address to you, is this a legit email address? Someone say, yes, Jim. Neepan. You're not going to say yes, Jim. Yes, that's great. This is a legit email address. It's RFC compliant. It passes the HTML5 standard regular expression for the email validation field. Now, look at the title. Even valid data can cause injection. So if your defensive strategy is to validate data and that's all you're doing, you are not writing secure software. Here's a valid email address that I'm adding to the middle of a SQL statement. And look at that final SQL statement. Look at this carefully here, right? Select ID, social security number, credit card number, mother's maiden name for the customers table where the email is Jim or 1 does not equal manico.com. Neepin, my good friend. We're friends, right? Thank you. 1 does not equal manico.com. What does that resolve to? True. And when you have an or true statement in any kind of query, what happens? All your where clause criteria goes away. So what dumps from this query? Everything. Game over. I got your whole customer table. So look at the title of the slide again. Even valid data can cause injection. So what do we need to do? By the way, where's the vulnerability in this code? This is insecure code. We're building a SQL statement where the data is being added directly to the query here. That's always an anti-pattern. What we want to do instead, sure, it's good to do validation, but the real answer here is parameterized query. I don't mean this in a mean way. I'm a Sicilian. Our idea of gentle is a little skewed, but if you're not aware of parameterized query, you shouldn't be writing code. So you shouldn't, because the destruction you can do is so deep. I can steal all your data. I could run OS commands against your backend database. I can modify any of your data, use it to compromise your infrastructure, not just steal data. So this is a really big problem. It's also very basic. Parameterized queries is defense we've known about for over 15 years. It's something that all developers should know. And the way this works, I'm a Java guy, I love Java. And so this is the trick. I'm building a parameterized call statement where the question marks are the placeholders for my input here. I bind that data into the placeholders. Injection goes away. Your queries run faster. Your database is more efficient. Why does this work? Because in the database, when you have a parameterized placeholder query, it gets grabbed by the database and your query plan's compiled right away, and then the input is sent into it. But the plan's already compiled, so we can't inject or change that query in any way. This defense is available in Java, .NET. It's available in any of your Hibernate abstractions. You can do object relational mapping. You can do query parameterization. Every language has some kind of parameterized query to stop query injection or SQL injection. But the problem is some variables cannot be parameterized. Look at this question mark, the first one here. Select name, color, calories from question mark. What is that question mark? It's a table name, right? Should you be parameterizing a table name? No, you shouldn't be. The question is, what if you're a developer who is parameterizing a table name? What does this imply? It implies that you're allowing your user to submit a table name to your application that you directly add to the query. This violates all that is good and just in programming. It also violates the data object access pattern, one of the earliest object-oriented design patterns. Your layer of your controller should be abstracted from your data layer. I shouldn't know table names or column names as a user. I shouldn't even know you're using a database, let alone feeding you a table name. If you have legacy code that does this, at least strictly validate so the table name submitted to you is specific to a discrete list of table names that are acceptable for this application. I'm going through this fast, but if you want to learn more about how to talk to SQL or an object relational mapping engine in a secure way, go look at this great website, bobbytables.com. Bobby Tables will show you how to do parameterization in every major language. Also, I want you to move to a much more comprehensive standard like the ASVS standard. This is the OWASP Application Security Verification Standard. It's about 180 requirements for secure coding, and SQL injection is discussed in ASVS 5.3.4 and a series of other requirements beyond that. I know a lot of us are agile. We don't like documentation or requirements docs these days. We just write code, whatever, DevOps, whatever you folks are doing. But we need to slow down when it comes to security. If we care about secure software, we need to have a clear formula of how to approach that as a developer. And this is hard work. It slows you down at first, but it's what is necessary if you care about secure software. And that's why so many of us don't. That's why there's so many hacking incidents, because this is tough. This is the most basic of all issues, and some companies still struggle with it. So knowledge, you as a developer, whether you know it or not, whether you believe it or not, whether you care about it or not, who here is a developer? Who here's main role in life? I'm a developer. I'm going to change, hands down, I'm going to change your title. You know what you really are? You're a security engineer. And whether you know it, believe it, or do it, the code that you're all pushing is the new front line of your organization. Who here pushes code live who pushes code live as part of their job? Whose code that they write ends up going live for their company? Everyone here. Guess what? You're a security engineer. Who has seen the drumbeat of security get louder in their job the last couple of years? Yeah, most of us. So here we are. Query parameterization, step one. Let's go up the stack now to a much bigger topic. Let's talk about authentication. Now, when it comes to authentication, a few big takeaways are, first of all, let's define this. What is authentication? Who wants to define this for me? What do I mean by authentication? Yes, sir. That's it, validating your identity and validating that you are who you claim to be. If you came to my party and I gave you an authentication-only invite, I have a party out in Kauai, we're gonna be drinking a few Coronas, you know, dancing, whatever we do at the party, right? And I gave you an authentication-only invite. That means you can show up at the door and ask questions. Oh, what's your name? Oren. Hey, Oren, welcome to the party. And you start to walk in, I'm like, wait a second, let me check your invitation. You're not authorized to do anything. Now, you can ask questions. Oh, can I have a beer? Oh, yes, you may ask, but you're not authorized. You can't have a beer. Well, can I come in? Oh, you may ask. You're authenticated, but you're not authorized to actually walk in. You may stand at the doorway and enter. Now, I'm sorry, Oren. I don't like Oren, but we're all friends, right? So I give you an authentication and a full authorization invitation. So Oren's standing there asking me questions. What am I saying to him? No, you're not authorized. Now, you show up. You're authenticated. I know who you are. But then you're authorized to drink beer, enter the party, dance on the dance floor, and so on. So you stop by, hey, Jim, can I come in? Yes. Can I have a beer? Sure, you're authorized. Come on in. And Oren's like, what about me? Can I have a beer? Let me check your invitation. Authentication only. You're out. Sorry. So what's an authenticated? So authentication is establishing identity. Authorization is access control. What data and features can you ask? That, by the way, was a joke that no one laughed at. I forgive you. So a session is an area of memory. And by the way, once you're authenticated, that triggers a session, right? And the session is some area of memory or storage on the server. In a web app, we use session IDs and cookies. In an API, we're usually going away from that, and we're using stateless mechanisms like a JSON web token. And how do we determine that a token that I give you that represents that you're logged in is still valid? It's all about digital signatures now and key management. That's the whole new frontier for authentication. But what I want to talk about now is password policy. I want to go from the coolness to the old school stuff, because first of all, somebody tell me what's a good password policy. What do you think is a good password policy in 2019? How long? 8 characters? I like 12. 12 is my preference, but you get the right idea. Something more than 8. What characters should we see in a password? What requirement should we put on our developers for a good password? Uppercase, lowercase, number, special character. That's traditional policy. And it's completely, it does matter. It matters greatly. But the old pattern doesn't matter anymore. What I want to show you in this is a new standard that defines what passwords all are about these days. So first of all, don't limit the password strength is our first part of new policy. What I mean by that, do you ever see a password that says you can't have a single quote in it, you can't have a certain special character in it? That's because some bank or company is scared about injection, so they take characters out of a password. This is a really bad idea. I should be able to take any piece of Unicode as a password item, or you're not secure in other areas. So that's step number one. But let me show you why I think it still does matter today. We're going to take a look at a new standard from NIST, and this is called NIST 863B. This is the U.S. federal government digital identity standards. A lot of us may not like NIST standards. I don't like them all, but this standard is fantastic. It changes the world of password policy in a very positive way. The first thing we want to address is credential stuffing. So credential stuffing is when, hey, by the way, who uses a strong password online? I hope you do. Who uses this? Let's have a moment of security confessions. This is a chance for redemption and healing. Who uses the same password across multiple sites? Sir, I expected better from you. What should you be doing? Using a password manager, having a strong, unique password for every different site. A lot of, even the good folks don't do that. And when you don't do that, if one application gets breached, what that means is they can use that credential pair, the email, password, the username, password, and use that to hack other websites. So what credential stuffing is, when I as an attacker see a breach on your website, and I go grab a username password that was leaked on one website and try it on another website, your bank, your healthcare site, your email account, game over all the way. So one of the critical defenses in authentication system today that almost none of us have is to be aware of credential stuffing. So when I, as a user, register for a new account or try to log in or try to change my password, you should real time check my username password pair and see if it exists in a public breach database, which we see on Pastebin. There are many open source projects that look at this. And if there is a known pair that has that breach, we should stop users from registering or changing their password to that known password out in the wild there. Also, what happens if Gmail got breached today and their entire username password database was stolen? Will that affect us in our other companies? Yes, it would, because attackers would take your Gmail password that was leaked and use them to try to break into your bank, your healthcare site, your gaming site, whatever else you're doing. So the moment a third party is breached, as quickly as you can, you want to get a list of all those usernames and lock them and make them go through password reset. And this is the main way you're being attacked these days. There's no way we're ever going to convince users to behave well on the internet. The other thing you can do is turn on multi-factor. Who here offers multi-factor in the service they're building? Like 2 of you, 4 or 5. Who has it as an option? Who does not even offer it? You should at least offer it. This is a defense we've needed for over a decade. If you do banking in Europe, it's required to do any transfer. So here we go. Credential stuffing, be aware of these issues. So now off to NIST 863. These are all the new rules of play for password policy. Rule number 1, don't limit the characters of a password. We just looked at that before. Number 2, the NIST standard says 8 characters minimum. This is super weak, which should be at least 12. So I think all the other requirements are spot on, but 8 is too weak of a password, especially if you don't offer multi-factor. My take on this is, if you offer multi-factor, 8 is minimally acceptable. If you don't offer multi-factor, then a 12 to 16 character password is a better minimum, right? So one of the big corporations I work for, they don't do multi-factor. They require a 16 character password for everyone in the company. Those who do offer multi-factor, a weaker password is acceptable. Next, block context-specific passwords. Like my password as an instructor for GOTO Chicago should not be GOTO Chicago. That's a context-specific password we should avoid. A little bit hard to build this, but not that difficult. Next, and this is also important, a defense that very few of us apply. Another way attackers go after you is they look at all these passwords that have been breached in the public. And they have this giant list of about 7 to 10 billion passwords that have been stolen in the last couple of years. Attackers will sort this list, have the most frequently used password first on their list, and use that common password list to attack your websites, attack users of your websites. What we want to do, recommended by the standard, is to have the top 50 to 150,000 passwords in the world today. Make sure that your users are not allowed to do this. This should be a moving target over time as well. Next, check against a list of breached username password pairs. That's credential stuffing that we just talked about. Next, brute force. Suppose I figure out one of your users is named admin. I'm going to try to go after that account. And what I'll do is I'll brute force it. I'll get one of these common password lists and go after that account. And your mission is to detect that I'm trying to brute force you. You see thousands of login requests per second, and throttle or block or somehow handle that brute force attack. There are many ways to do this. Next, don't force special character rules. To your point, all those special character rules, get rid of them. They're useless. They don't help security. Next, stop doing password security questions or hints. The most common password hint in Windows is your password. And security questions, I can look them up in social media. What's your favorite car? I'll figure it out in your Facebook account. Next, no more mandatory password expiration. When you force a user to expire their password every 3 months, they end up putting a sticky note on their desktop. In fact, the state of Hawaii sent a false alert out saying nuclear ballistic missiles are en route. That was a difficult morning. And so my wife's waking me up. Hey, Jim, we have nukes en route. And I'm looking at my text. I'm like, oh, yeah, we do. Okay. I went to my neighbor's next door. He's in the military. He's like, what should we do? He's like, I'm drinking some wine, brah. I'm like, all right. So it's like 8 in the morning. Nuclear missiles are en route. I'm in Hawaii in a small island. I got nowhere to go, right? So what do? My wife's like, I'll be right back. She went and grabbed a bottle of Dom Pignon 79, I think, that we got for our wedding. My wife goes, wait a second, Jim. She pops the cork. My wife is a fine lady. She's a very diminutive, very respectful woman. She goes, I got this, Jim. She pops the Dom, lets it foam out, and does this. Chug, 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 chug. Here you go, Jim. I'm like, this is a good thing to do. I'm okay with this. It was a false alarm. No nukes show up in Hawaii, thankfully. It was a very difficult morning. I'll just put it that way. Existential crisis. But anyways, fast forward a few days later, and we're now at the news. We're filming the actual command center of Hawaii. And the main response guy's talking about what happened, how he's trying to fix it. And behind him, the camera had all the computers of the emergency preparedness center of Hawaii. And guess what was right there on camera in a big yellow sticky note? The admin password for the entire state of Hawaii response center. Yeah, because they had to reset it every 3 months. Anyways, next, this is great. Allow all printable ASCII characters, including spaces, as well as all Unicode characters, including emoji. A very famous security incident was a security researcher using the poo emoji in her security password, and her security question, which ended up dropping the entire IT system of a top 10 global bank. Yeah, people have it on their keyboard. You've got to support it. And so a few other notes. At the bottom here, use a password strength meter. Make sure you can paste a password into your password field. A lot of people block it. It's anti-security. I need to paste it for a password manager to work. And for mobile, let me see the password. It's unfortunate, but mobile keyboards are inaccurate to even this day. All right. I'm going to skip this slide. We're going to skip this slide. So does this password work in your system, by the way? Is this a good password for your system? It shouldn't be. It's long enough, uppercase, lowercase, number, special character. It's long enough, 1, 2, 3, 4, 8, like 11 characters. Looks great, but it's one of the most common passwords for enterprise systems. It's got the word password in the middle of it. It's one of the most common patterns for passwords. No one should accept this password. It's an example of a very bad password policy. The next thing that goes wrong, people hack your website, SQL injection, other kinds of data theft, and they steal your password data out of your database and then post it. Who has this happened to? Who's had their website, username, and password exposed to the world? Dropbox, eBay, the RockU network, the entire Sony PlayStation network was down for a month a few years ago. Been many password breaches across the world. We have to be ready for this by storing our password in a secure fashion, and very few developers get this right. A very common study recently, they asked 43 freelancers to build an authentication system, and 26 of them stored it as plain text. Anybody want to tell me how should we store a password in our database? What algorithm is acceptable for password storage? You mean like SHA-1? SHA-3? SHA-2, SHA-3? If you're using SHA-1, SHA-2, SHA-256, you're doing it fundamentally wrong. Because you should never use, why is a hashing algorithm bad? Because it's lightning fast. Let me explain why and point to what a real algorithm is for password storage. Now, when does password storage matter? When you're doing offline attacks. When I've stolen your data and I have it offline, I can throw supercomputing capacity at your password storage system to try to crack it. And so, and again, I can use supercomputing capability using cloud services or GPU rig, like a video game machine with lots of video cards in it. And who's had their password stolen? Everyone on screen. Yahoo down here is now Oath. That's like 7 billion passwords they leaked. They lied about it many times. Oops, let's just move on. So how do we get this right? We want to avoid hashing by itself. We want to avoid encryption. These are both fundamentally bad ways to store a password. We want to use a key derivation function or a password hashing function with the proper salting, with proper password policy, banning common passwords. We'll look at this in just a moment. In fact, again, suppose you're storing a password using just a hash. I'll do this. I have one of these at home. This is my password cracking rig. Guess how many hashes per second. Are we doing a picture? Wait a second. I'm ready. Thank you. Okay, so let's look at the GPU rig. Guess how many password hashes per second I can try with this rig. I spent about 5,000 on it. I have 4 of these machines networked together with open source networking. How many SHA-256 hashes per second can I try on this rig, would you say, sir? Take a wild guess. Higher. Billion. Higher. Trillion. There you go. 950 billion. A customer gave me 1 million passwords to crack, all hashed. My rig fired up and kept shutting down. I spent the day debugging it, supercooling it, water cooling it. I chainsawed a hole in 2 of my office doors and put fans in to make a wind tunnel. You know why it finished so quickly? It was done. 1 million passwords cracked in 2.5 seconds with this. So, I can also do it online. And it's not me, it's a special software called Hashcat. And they gave me easy passwords to crack as well, but it worked. I also have online services to crack hashes, very easy. So here's your best practice. Number 1, use a salt. Number 2, use SHA-512 to hash it, and then use Argon2i, bcrypt or scrypt to actually do the protection. We'll explain why in a second. And then use encryption as a final step. Let's do this. All right. So why do we use a salt? What a salt is, when the user registers for a new account, I'm going to generate a large random string for that account, at least 128 bits. I like to use much bigger salts for whatever reason, but 128 is what the cryptographers say is okay. What that means is, suppose you and I have the same exact password. In fact, one of my powers is I can guess your password. May I guess your password? FluffyBunny1, exclamation point. It's my password too. It's a special power. What if we use a hash, SHA-526, to store our passwords? What's our hash going to look like? And we got to change that. So when he registers this account, I'll generate a unique random string for his account, do the same one for my account when I register mine. We both have like at least a 128-bit random string, or at least more important than random, different string, unique string. So when I say your salt plus FluffyBunny1, my salt plus FluffyBunny1, and then I hash it, we've deduplicated that ciphertext or hash when the plain text is the same. This is a core part of deduping passwords across a password storage system. Next, we want to hash it. One of the algorithms I recommend is bcrypt, because it's slow, and you can tune it to be slow. Why do I want to make my password storage algorithm slow? So I can't do 1 trillion attempts per second. We'll look at the numbers of that in just a second. But with bcrypt, it truncates after 72 bytes of password. With bcrypt, if the password's too long, it's a denial of service vector. It's too much work to crank out that bcrypt hash. So if we take the password, the salted password, and then we hash it, take this to 512 bits, and then we bcrypt it, I can bcrypt 512 in a reasonable amount of time, and now we have a good workflow for secure passwords, even in the face of these problems. So hashing is just one step. And if you only hash, I'll pop your password pretty quickly, even longer ones. Number 3, these are the actual algorithms. So when I say, how do you store a password, the answer needs to be one of these 3 algorithms. Algorithm 1, bcrypt, this is default in PHP, your password hash function. It takes a work factor. So when I say bcrypt work factor 1, it does a couple loops. When I say bcrypt work factor 13, it does many thousands of loops to purposely slow it down. Why do I want to make my password storage algorithm slow on purpose? Like half a second to a second delay. Why do I want to do that? So when the password's stolen, I can't do 1 trillion attempts per second. We're going to slow it down. We'll look at those numbers in actually the next slide. Here's the next slide here. Boom. When I'm using here's hashes per second, and here's the algorithms that we care about: MD5, SHA-1, or bcrypt13. With MD5, same hardware, 200 million hits a second. SHA-1, 68 million, same general scale. Bcrypt work factor 13, the minimum good work factor in my opinion, 390 per second. The difference is dramatic. You have to take the hit yourself as a developer. You're gonna feel some performance hitting on the server when you do this, but we need to take that hit. And because what used to take me a couple seconds to get your password now takes a couple weeks, and it buys you time to handle the incident. Let's go back to this for a second. Bcrypt is the weakest of the strong algorithm family. You can also use scrypt, which will not only give you a time delay that you can add, you can also consume memory on purpose as well. Argon 2i has a time cost, has a memory cost, and it has a parallelism degree. I can only use one thread to compute it at one time. This is now, even if your database is stolen, if you're using these algorithms correctly, it's going to take me as a hacker a long time to crack your password, which gives you time to handle the incident. And this is available in Java. It's available in PHP. It's available in every major language these days, at least the bcrypt algorithm. And when we're looking at attackers, this is the best of breed. I used to recommend PBKDF2 unless you're building a federal government system. There's no need to use it. It's a federal standard, but it's pretty bad. scrypt, the best choice is going to be bcrypt, which uses 4K of memory per run. If you're going to use scrypt, use at least 16 megabytes. This is what I use today. I use scrypt at 16 megabytes. It doesn't hurt scalability that much, and we can tune it to be as slow as we want it to. You want to make that tuning at least a 13, preferably as slow as you can handle. Last step, do an encryption round at the end. If you have good key management in place, like you're using a key management system or other good crypto vault to store your keys, go ahead and encrypt as a final step. If you don't have keys available, don't worry about it. You can skip this step. This is an extra step to consider. That's what password storage is today. This is not my research. These are cryptographers and other community members of the security industry who've made these decisions long time ago based on the kind of attacks that are out there. But more important than password storage, don't allow passwords by themselves to ever access a high-risk system. Multi-factor is required in any European banking. And these days in the US, most banks have multi-factor. Anybody use an online bank that doesn't have multi-factor? Stop using that bank. They don't care about security, obviously. Let's move on here. Let's go to a new topic here. And so, let me show you the algorithm sequence. When I'm going to store a password, again, I use that unique user salt plus the password. I have a salted password. I'm then going to hash that salted password, and I have a salted hash. Then I'm going to run bcrypt work factor 13 through that salted hash, getting me back to 512 bits, and then encrypt it as a final step. If you have a good password policy, 12 characters or longer, if just passwords, it's going to take me hundreds of years to crack your password on today's hardware. And then next, how do I verify? You try to log in. You give me your username and password. I look up your user salt in the database, add that to the submitted password, hash that thing with SHA-512, run that through the bcrypt, decrypt the encryption if you have it in place, and then compare the bcrypt hash with the salted hash. These slides will all be published at the conference if you don't get a picture. Are you going to do a picture? Are we doing a picture? Get your camera out real quick. I want to make a sound effect. Sorry. Let's do it. Quick. Quick, I got a talk to do. You got it? Thank you. At Manico, tweet that thing out for me if you don't mind. All right, where are we? Boom. So, look at the ASVS 2.1 section. Very detailed discourse on password security, applying all these new NIST standards. I think this is righteous. Like, I've been following security for a long time. Password policy as we know it today is atrocious. This is written by Jim Fenton and a team at NIST, real world researchers who understand how apps are really attacked. This is something to look at. And by the way, if your system has SHA-512 or a hash, That's exactly how I'm attacking your system. I'm going to steal that data, crack passwords relatively fast. I would prioritize highly moving to a more secure methodology. Or even better, consider using a third-party service, Auth0, one of our vendors here, Google Login. I think Google Login is way stronger than building it yourself, by far. Turn on multi-factor. Google has a lot of PhDs, spends a lot of money. Facebook Login, let's move on. Okay. That was very opinionated. Okay, let's talk about sensitive data exposure, right? So there's two things we got to get right. I'll move through this fast. Number one, how often should we be using HTTPS? Is there ever a good excuse to use HTTP for anything we do in modern programming? Anybody want to challenge me on this? Who says it's okay to use HTTP? Raise your hand. I'll be respectful, I promise. You're wrong! No, I'm sorry. I'm going to be respectful, I forgot. That was just joking, everyone. Just kidding.
Binary repositories to allow organizations to better cache the artifacts internally.
I don't understand.
They have specifically chosen to use it on like Maven, I think, and stuff, so that jars can be cached more easily internally by organizations.
Think about this. So you're using Maven to put your source code in. Do you have any contractors using Maven? External to your system? Probably. You're going to push this live, and now you're basically saying all of my source code, I'm going to let flow over the internet in plain text. I think code repository, that's the keys to your kingdom.
Binary repositories, not code.
So the jars that you're pushing live, that's the same thing as code. Jars or bytecode. I can use JAD to decompile that in real time pretty easily. So I mean with the respect, I don't think that's a good use case. I think especially like GitHub, Git, it's all over secure encryption, right? I mean this with, when I was yelling, I was trying to laugh. No one laughed at that attempt at humor. I don't think there's any good excuse to use HTTP these days. We want and it's not even enough to use HTTPS. We need to use HTTPS in a well-configured way. If you want to verify how well your server is configured, the standard in security today is SSLlabs.com, right? That's an online free verification service. It's from a vendor, but it's written by a gentleman named Ivan Ristic. He wrote the book Bulletproof TLS, one of the best researchers in the world. So his site, SSL Labs, to verify your config, but the best out there. You want to get an AA+ on his scanner to make sure you're configured properly. I was only kidding. No one laughed at that joke. Oh, he's yelling at someone in class. Yeah, it's usually bad form. I was just kidding around. Okay. The other thing is when you're doing stored crypto, I recommend the hardest part about crypto today is where do you put the keys? The answer is use a KMS or some kind of vault, a key management system or a vault. Putting a key in a database on your file system, these are usually bad ideas. In fact, if your code can access a key, I think that's a bad idea. So I use a kind of vault where you send the data into the vault, where in a sealed environment, I encrypt, decrypt, or sign, and pass that data out of the vault without ever exposing my key to your code. That's the ideal when it comes to cryptographic services. Also, when you're using libraries, my favorite by far is Google Tink. It's for C++, Go, Objective-C, Java. The reason this is so powerful is because it has native integration with key management services. All the best practices of low-level crypto are built into this library by some of the world's best. If any of us in this room had to build a crypto system, myself included, we would likely get it wrong if we're doing low-level code like in C or Java or other low-level language. So please use a well-vetted library to do this work for you. In my world, this is one of the best out there, Google Tink. And so there's also, if you're doing C, C++, I recommend Libsodium. It's written by Dan Bernstein, a local Chicago professor. Round of applause for Chicago. Woo-hoo. Okay, so, and he's an activist in crypto, really high-end standards. Another best practice in crypto is using Libsodium. So again, you want to protect data in transit and at rest, depending on the system. The first thing you do is do data classification, understand what data is sensitive and what to do with it, and use well-vetted systems to lock it down. We have the transport layer cheat sheet and SSL Labs for guidance, as well as the cryptographic storage cheat sheet from OWASP to help you along your way here. Be careful. This is one of the hardest things to do in the world of coding. XXE, we're looking at the OWASP Top 10. We're looking at some of the high-level issues that we see in secure coding today. Let's talk about XXE. We mentioned this in the beginning, but here it is. If you have an XML web service, legacy, that hasn't been getting maintained like your other services, you're likely vulnerable to this. This is a common problem. This means that your XML parser has enabled the external entity processing part of the XML parser, which is turned on by default. So I can say element foo any, entity XXE is a system resource on your file system. That's your Unix password, oops. And then there's foo XXE where I render the results. This is a great surgical attack. I find a legacy XML service, one request, boom, and I got your password file, which I can analyze offline, crack your password, and use it to then get advanced access to that server. This is a trivial attack. It's the real-world attacker's best friend. So what you need to do is either shut down your XML services or configure your XML parser to disable all of these features. And if you do need them, we have to validate which one of these external entities are acceptable. There's also another attack called the billion laughs attack. This is when you leave DTD inclusion and recursive parsing enabled in your XML parser. So I see LOL9, and I have 10 LOL8s, and down the path here. This is 3 times 10 to the 9th power entities. This is 3 billion entities resolved in a couple K of data. Your server is going down like the Titanic. It's a denial of service attack. So the point, and to configure this in certain languages is quite challenging. It's non-trivial. So what you need to do is go to your legacy XML services. Check to see how your XML parser is configured. Shut down these additional features which rarely are used in modern development so you're not vulnerable to these problems. So next, broken access control. So one of the key, we're talking about the OWASP Top 10. The last few we'll go through quickly. The broken access control, here's one thing. Here's a web service talking to some email message, and there's the database query. How would you hack this feature? How long would it take you to write a script to try every possible message ID and extract the entire message database from my system with this code? Are you a full-time employee? Okay, so if you're a full-time employee, this is a couple minutes. Anybody a contractor? It's a 2-week project. Oh, yeah. So, all right, so yeah, so what you want to do here is you want to go select star from messages where the message ID is a certain number and the owner of that message is the same owner ID in the database. This is a very simplistic ownership reference to help lock down theft of other people's data, and this is a common problem. Here's my challenge to you. Go to any API you're developing. Look at any number being fed into your API, in the body, in the URL, in a cookie, and start changing that number. If you can start to pop other users' data, you have an access control problem. And this is an ultra common problem across API development. In fact, there are many bug bounties programs, like at Facebook, through many other companies. All you have to do is go fiddle with numbers and APIs, you can get a bounty. It's a great way to break access control. And so I also want to recommend that also that stop hard coding roles in code, right? I recommend we move to a more permission or capability model. And so to look more about this, we have the access control cheat sheet. There's also a NIST standard 800-162, which talks about attribute-based access control, next generation, more capability-based, where I'm not looking what the user's role is, that's the policy. I'm looking at what they're trying to do, then looking up the policy in a database. A6, security misconfiguration. How much configuration is in our software these days as a developer? How many config files do you got to manage in your apps these days? Can we say quite a bit? Is that fair? Especially as we move to cloud, move to some of the more advanced programming, we're doing a lot of configuration to set things up. I'm configuring my authentication server, I'm configuring my access control layer, I'm configuring my object relational mapping engine, and I live in these configuration files. It's horrific. YAML. YAML, okay. So all I'm trying to say is, if you can't verify that it's truly secure, then it's not secure. And some configuration, like updates, is trivial. Other configuration, like advanced Spring security configuration, that is really difficult to get right. You need a good expert to verify some of your more complex configuration. It's a place where mistakes can be easily made from a security point of view. A7, cross-site scripting. We're now moving to the user interface. How much time do I have? I can do this, 5 minutes. So with cross-site scripting, anytime I can add content to your website that another user can look at, it may be a problem. Like here, I can change this piece of the URL. It will change what gets rendered here. I can then swap it out with the script, email that, or send that to a user. When they click on the link, they're executing my script at evil.com, and I can do all kinds of evil things with cross-site scripting. I can add any JavaScript to your page. And if I can add any, and I can also do this by storing it. I'm sorry, let's go here. I can do this by saying, I'll update my profile with an evil attack. I'll get somebody else to look at my profile, and my profile code lands in the victim's browser. When that executes, I can steal anything I want from that application's page. Here's a way I can steal data. Again, I update my profile, and I add this to my profile. What I can then do is, I build an evil URL in your browser and grab your cookie and add to the URL. I then make an image object in JavaScript, and then, that's not the right, it's close enough. But the image, this should be new, I did this so it makes sense. It should be really like new object, IMG type. It's not the right call, but forgive me for that. Image.source in JavaScript loads the image. And by doing so, it sends your cookie to my website. What if I can steal your cookie? What can I do with that? I can impersonate you. It's called session. I don't know your password. I can't log in. But if you're currently logged in, I can impersonate you and start committing actions as if I was you. So, and there's many other attacks. I can deface your site, steal any data, do lots of other attacks against you, like this. The most dishonorable football team in all of NFL is, of course, everybody, say it, the New England Patriots. They should be removed from the game. And who's the great team? Any other team is awesome. I'm going to loop through this marquee, the New England Patriots are full of lying cheaters, any other team is awesome, and then end the marquee. This is the defacement. Document, body, inner HTML. Oops, sorry. Document, body, inner HTML. That lets me update the body of your whole web page. Game over. So I can deface your site in a trivial fashion with JavaScript. And this is my grid for how to really lock it down. It's a combination of escaping, sanitizing chunks of HTML from a WYSIWYG editor, as well as using JavaScript safely. And there's a lot of guidance at OWASP in how to do this securely. The cross-site scripting cheat sheet, the DOM-based cross-site scripting cheat sheet, the filter evasion cheat sheet for attackers. And I really recommend you look at this new technology, content security policy, to change how JavaScript runs in your website. You can also use a new thing called trusted types being worked on to limit what the browser can do. Insecure deserialization, second to last topic. How much time I got? 3 minutes? 2 minutes. Okay. Insecure deserialization, stop deserializing untrusted data. And if you're taking a big blob of binary from the outside world and deserializing it, I can run operating system commands against your server. And most of the defenses people talk about don't work. And if we look at the research from Alvaro Munoz, he shows us that almost every single JSON and XML parser is also vulnerable to this problem. So you got to ask yourself, have you updated your third-party libraries since in the last 18 months? If not, then you're probably vulnerable to this if you're doing deserialization. Here's some guidance on this particular topic. I just put it this way. Do not deserialize untrusted data from a user source. Use an XML or JSON parser and keep those parsers up to date on a daily basis. That's your best path today. Using vulnerable third-party components. Why do we care about this vulnerability in struts? Whoa. Why do we care about this vulnerability in struts? it took down Equifax because I didn't keep a library up to date. So I'm going to go right to the conclusion here is if you're in Java, use these different scanners, open source or commercial, to make sure your third-party libraries are up to date. If you're doing .NET, you got the RetireNet project, which will scan your code looking for insecure third-party libraries. This is NPM. This is called a security shit show that I've never seen before because most of JavaScript is insecure and NPM thinks there's a couple hundred vulnerabilities at best. There's so many undiscovered vulnerabilities here. This is one of the biggest problems in modern computing. So please use retire.js. The NPMS auditor is getting really good. There's also node source trusted modules which manually and automated review modules before they publish them to you to use. And so, again, we have the OWASP Dependency Check open source project, which will also scan your code base looking for insecure third-party libraries. My opinion, this is number one. It's almost impossible to well-manage third-party libraries. Very few companies get this right. It's a tragic problem in the world today. Last but not least, log a lot. I recommend at the very least you log all authentication events, all access control failures, and all input validation failures. That will give me as a security person who's monitoring your logs very good visibility into any modern attack happening against your server. So we may miss secure code. We can at least rigorously log all of our security events in a relatively easy way so we have information when we're being attacked. So what do we need to do? Use a standard like ASVS. Look at the OWASP cheat sheets for continued guidance and make sure you're testing your applications for security on an ongoing, daily, continuous basis. That's what DevOps is, using an automated pipeline to run security testing on a daily basis. And we're at time, we did this. If you have questions for me, I am jim@manico.com. I live and breathe this. It's my passion and my job. Always happy to answer questions. That's the show. Thank you so much for being here for this talk.